Welcome to this video on AutoSys AWS Batch solution. In this video, we will explain the AWS Batch integration with AutoSys and what it brings to the AutoSys user community. We'll provide some technical insights so that the integration components are clearly identified and the deployment sequence is understood. We'll focus on the design and execution sequence of launching AWS Batch job template. Finally, we'll run through a demo. AutoSys plays a central role in orchestrating operations across multiple environments, including the cloud. AutoSys synchronizes these processes with other non-cloud operations. By integrating AWS Batch, we can configure process automation centrally in AutoSys and then trigger, monitor, and supervise everything in one place. AWS Batch processes can then be synchronized with all other environments routinely supported by AutoSys, like applications and databases. AWS Batch's role is reduced to only submitting the jobs. All other functions, especially those pertaining to automation, are delegated to AutoSys. This means that we don't have to log into the AWS Batch environment and keep on refreshing it by ourselves. We just need to specify connection details, such as endpoints and authentication settings in the job definition, and let AutoSys manage all the execution and monitoring aspects in any number of AWS Batch environments. AutoSys lets us build configurations with intuitive interfaces and supervise them in simple dashboard tools designed natively for operations. Statuses are clearly marked, and retrieving logs is done with a click. From an operations perspective, AutoSys highly simplifies the configuration and orchestration of AWS Batch job. Externalizing operations to a tool with a high degree of third-party integration means we can synchronize all cloud with non-cloud workload. Using various agents and job object types, we can build sophisticated configurations involving multiple applications, database packages, system processes like backups and data consolidation, file transfers, web services, and other on-premise workload. The job submission sequence is fairly simple because all job definition properties are stored in the AutoSys plain old Java, or POJO job. All target system properties are defined in the J2EE parameters, the AWS Batch endpoint, which is the submit job REST API, access key secret, instance profile, and so forth, depending upon different authentication. Let's look at the sequence of execution. We start with the three main components: AutoSys Scheduler, the System Agent, and the AWS Batch Server. The POJO job is submitted to the System Agent by AutoSys. The agent acknowledges receipt of the job from the scheduler and initiates communication with the AWS Batch Server. It needs to be authenticated first. AutoSys supports various authentication types such as EC2 Profile Instance, OAuth, External Provider, SAML, and Assume Role. In this video, we are using the OAuth authentication, which uses a combination of access key ID and access key secret. Once authenticated, the agent submits the job to the AWS Batch Server as a POST request. The AWS Batch Server identifies the matching batch job and executes it according to the specified parameters. This may involve provisioning the required compute resources, scheduling the job for execution, and monitoring its progress. The batch job execution returns a JSON response which contains the execution details. The AWS Batch Server and System Agent then monitor the job. During monitoring, if the cancel call is initiated, the cancellation process is prepared and triggered. An API call is made to the AWS Batch, which responds with either success or failure. Once it is complete, the monitoring status is printed indicating whether it passed or not. If the cancellation doesn't occur, then the monitoring continues until it reaches the terminal state. Upon completion of the terminal state, such as success or failure, the job will be completed on the AutoSys side until it reaches the final state. Once it obtains the final state from AWS Batch, it marks the job to the final state in AutoSys as canceled, succeeded, failed. Let's look at how to deploy the integration. First, ensure we have the Application Services plugin installed as a prerequisite. The Application Services plugin and Pojo extension have the CFG extension. In older agent versions, you might encounter a PAK file instead. Next, download the plugin extension package from the marketplace. This package contains all the necessary elements. Unzip the package and extract the content into a temporary folder. Next, we must stop the system agent with the cyb agent-s command. From the extracted content, navigate to the folder labeled 11 or 12 and copy the jar files. Navigate to system agent install directory /jars/ext folder and paste the copied jar files. Now, restart the system agent with the cyb agent-a command. Remember, this integration uses AWS Batch's public REST API. Finally, design the AutoSys Pojo jobs and execute them on the AWS Batch server. In our demo, we will first briefly walk through the AWS instance. We will then create an AWS Batch Pojo job in AutoSys and then execute and supervise it. Let's start with what is AWS Batch and what does the AWS Batch instance look like. AWS Batch helps to execute the workloads directly on the AWS cloud. It automatically provisions compute resources, compute environments, and optimizes the workload distribution based on the quantity and scale of the workload. In AWS Batch, we have several components, one of which is the compute environment. A compute environment is a set of compute resources that are used to run the jobs. Currently supports Fargate, EKS, and EC2 environments. Once the compute environment is set up, then you can set up the job queues. When you submit an AWS Batch job, you submit it to a particular job queue where the job resides. So until the scheduled compute environment is free, it will be in the job queue. Once the environment is free, it will pick up the job from that job queue and execute it. As we can see, we have multiple examples created here for the job queues. Next, we will discuss the job definitions. Job definitions are the blueprint of how the job will be run. Here you can see if the job definitions that are already created. Once you have created a job definition, you can start the plugin extension jobs. Now that you have learned about the few key AWS Batch components that need to be set up beforehand, let's now proceed to AutoSys environment to create a Pojo job. Let's log in to AutoSys. Click the Quick View tab to view the job definition. Select the job to open the job definition. For the demo purposes, we have already installed the agent on this machine and we have already defined all the fields. Once the job is open, click on the Quick Edit button to view the different parameters that are required to be specified. Select the machine and the agent where you want to execute this job. We have to give the class name and AWS Batch, then provide the method name. Specify the class name, which is the AWS Batch, and the method name, which in this case is submit job. The endpoint parameter indicates where the AWS Batch service resides. As mentioned before, AutoSys supports EC2 profile instance, OAuth, external provider, SAML, and assume role authentication type. Depending upon the authentication type you specify, the methods vary. Here in this demo, we have used the OAuth authentication, so we have to specify the access key and the access key secret. Access key is the identifier and the access key secret is the corresponding secret password. The region parameter indicates the geographical region where batch computing jobs will be executed. The job queue parameter specifies the name of the job queue within AWS Batch where batch computing tasks will be submitted and processed. The job definition parameter specifies the name of the job definition within AWS Batch. This job definition contains the configuration details for how a specific type of batch job should be executed. The job name parameter specifies the name of the batch job being submitted to the AWS Batch server. This parameter helps to identify and track the specific job within the batch computing system. The container override command specifies a command that overrides any existing command defined for the container job within AWS Batch. This allows for customization of the command executed within the container during job execution. The job attempt parameter specifies the number of attempts made to execute a batch job within AWS Batch. The execution timeout parameter specifies the maximum amount of time allowed for the execution of a batch job within AWS Batch. If the job exceeds this timeout duration, it will be terminated automatically. The max retry parameter specifies the maximum number of times a batch job status will be fetched within AWS Batch for monitoring purpose. The sleep interval parameter in J2EE specifies the duration of time that AWS Batch will wait between each retry attempt for a batch job. The failure interval parameter specifies the amount of time in seconds before failing the job due to API failure. The log level parameter specifies the level of detail for logging information related to batch job execution within AWS Batch. Once you have specified all the J2EE and other parameters, click Commit and close it. That completes the job definition. Let's now start the job. Once all the parameters are defined, select Start the job. The confirmation will appear. Click Yes to confirm. Notice the run numbers for the job execution is 3829 and the status of the last job is marked as success. If we refresh, it triggers the new execution resulting in the increments of the run number from 3829 to 3830. The status being is changed to running. If you want to check the spool, select the spool file and click on the Go button. You will be prompted to specify the number of lines you want to display and go here and check the logs for the same. As you can see, the job has started and the retry attempts are made to get the status. A successful job. As we can see, we are providing all the parameters. We are printing that and then the job starts. What is the response to that job? After that, we started with the monitoring part. You'll find a clear display of all parameters passed by the user. The response of the job when the job started. It shows the details of the monitoring. It also shows that after retry 2, it returned the succeeded response. Once the job reaches its terminal state, it gets marked completed and the AutoSys job also goes to the completion state and any downstream job in AutoSys gets triggered. We can see the job completed on the AWS Batch side and the status we are getting is complete. Now, let's take a quick look at the status of the job in the AWS instance. As you can see, these were the jobs that we triggered, and the job is completed at this time. This concludes the demo of how AutoSys can integrate with AWS Batch to execute and monitor various jobs. Thank you for watching this video.